So very good morning to one and all. So this is S. Nakul Dev, Assistant Professor, Department of Chemical Engineering from Hindustan College of Engineering and Technology. So today I am going to discuss about the basics of heat transfer, where we are going to study about the modes of heat transfer and various laws including in your heat transfer. So this is the general examples of modes of heat transfer. So as we already know about the basics of conduction, convection and radiation. So this is a very familiar examples. So take a water in the beaker and just simply heat it. So your surface of the condenser, it means that your surface of the vessel, it gets heated, that will be termed as your conduction. And when your water starts to boil, becomes a vapor, it will be your convection. And radiation, the heat which is flows outside, that will be called as a radiation. So the definition will be the transfer of heat or electric current from one substance to another by direct contact will be termed as your conduction, and the transfer of heat through a fluid caused by the molecular motion will be termed as your convection, and the energy that is radiated or transmitted from the electromagnetic waves will be termed as your radiation. So this is a various so we'll be discussing about the various laws of heat transfer. So first one will be the Fourier's law, which states that the temperature gradient, that will be your heat flux will be directly proportional to the temperature gradient, and the time rate of heat are proportional to the area at the right angles of the gradient through which the heat flows. So Fourier's law is the other name of the law of heat conduction. So in some question papers or in some technical HRs, they will be asking about the what is the law of heat conduction. But we will be very familiar with the Fourier's law. So this is another name that will be the law of heat conduction. And Newton's law of cooling, which will be stated for the convection. Fourier's law will be termed for the conduction, and Newton's law will be termed for the convection. So which states that the rate of heat loss of the body is directly proportional to the difference in temperatures between the body and its environment. And the mathematical formula will be the Q by S equal to H into T minus TS. So TS will be your saturation temperature and T will be the atmospheric temperature. And Stephen Boltzmann law for the radiation, that states that the total radiant heat energy emitted from a surface is proportional to the fourth power of its absolute temperature, and the mathematical formula EV will be equal to sigma T4. Then Wien's displacement law, which states that the black body radiation curves for the different temperature peaks at a wavelength which is inversely proportional to the temperature. The lambda max will be equal to V by T. And black body radiation, the black body must emit radiation at the same rate as it absorbs, so it must also be a good emitter of radiation, emitting electromagnetic waves of as many frequencies as it can absorb, and that is the radiations emitted by the black body will be known as black body radiations. Thermal conductivity, so general thermal conductivity of the symbol will be K and the unit will be watt per meter Kelvin, and it is generally refers to the ability of a given material to withstand the heat. And heat transfer coefficient, or the film coefficient, we can term also film coefficient, which is proportionality constant between the heat flux and the heat transfer driving force for the flow of heat. It is used in calculating the heat transfer typically by convection or phase transition between a fluid and a solid, and the unit will be the watt per meter square Kelvin. Then effect of temperature on thermal conductivity, so very important basics concept these are all. So with an increase in temperature, the electrical conductivity of a pure metal decreases. This implies that the thermal conductivity of the pure metal shows little variance with an increase in temperature. However, a sharp decrease is observed when the temperature approaches 0 Kelvin. The thermal conductivities of the non-metals are primarily attributed to lattice vibrations, and the temperature decreases to a point below the Debye temperature, the heat conductivity of a non-metal decreases along with its heat capacity. So thank you. So these are the very basics of heat transfer, which will be very useful for your interview basis when you go for some technical companies. That definitely, if your area of interest will be in heat transfer, so these are the very basics formulas and laws. So it will be useful for your interviews. Thank you very much.